Thank you guys, thank you all actually for coming to my talk. My name is Mehul Shah, I'm the CEO of Aaron, and I know they called us out in the keynote yesterday, so I really want to thank everybody that put together OpenSearch Con. This is my third one, and I'm really happy to be back here. Today I'm going to talk about Luna. I know LLM-powered unstructured analytics is a mouthful. We've been working with customers for a couple of years now as they've wanted to analyze all of their unstructured data or get answers from their unstructured data. And what we found is that RAG, sort of the sort of dominant technique out there right now for answering questions, isn't quite good enough. And so that's basically the main takeaway that I want you take home today, which is that we need to think about different ways or sort of database style techniques for analyzing unstructured data, and that's what I'm going to talk about today. A little bit about us. We're a small startup bringing generative AI to search and analytics. Our founding team have a bunch of folks from veterans, I would say, from AWS, Google, and Meta, and we've got some key investors from the Valley here, Factory and 8VC, that have backed us. I've been part of the OpenSearch ecosystem from the beginning, and I'm really, really excited about the change that's happened most recently, which is now that OpenSearch is really in the hands of an independent, neutral foundation, the Linux Foundation, and the creation of the OpenSearch Software Foundation. We're founding members. We have technical folks from our team on the technical steering committee. More importantly, we've been contributing to this code base consistently since we formed. The most significant contributions were our conversational search features, in particular conversational history and the RAG processor in search pipelines. So you can build your RAG systems, your chatbots, and so on using OpenSearch, the tried and true system that's been out there for ages. So what's our product? Our product is a system called Sycamore. It's also open source, 100% Apache licensed. It's an AI-powered data preparation and analytics system for complex unstructured documents. What do we mean by that? Well, exactly what you could imagine. These are PDFs, Word documents, PowerPoint, HTML, and these things typically have a variety of things in them, not just text, but also images, tables, figures, and so on. And what is Sycamore good for? Well, it turns out initially, about a year ago, we launched Sycamore and our company at this conference, and we were largely talking about doing ETL on documents, chunking, enriching those documents, and then loading them into OpenSearch so that you could build search queries, okay, or RAG. And what we've now done is added a layer on top of all of this for doing analytics over your unstructured document. And so one of the things that's benefited us from working with OpenSearch is OpenSearch's features that had all of the things that you needed to be able to go and implement a lot of the analytics that we're going to be doing. All right, so that's the sort of quick little introduction of what I'm going to be talking about. I want to dig into some of the use cases that we see with our customers that motivated the need for a new paradigm that we call Luna. I'm going to actually try to show this to you in action right here. I'm hoping that the internet gods are with us and the whole thing works well. Then I'll actually dig in and show you how we actually implement this technique in Sycamore. And then I'll leave you with some parting thoughts on where I think all of this stuff is going and open it up for questions. So as we started working with customers, we saw customers across the gamut. Right? So financial services companies, we were working with individual journalists and doing investigative journalism, companies also doing, pharmaceutical companies doing marketing analytics. And what we saw was that they didn't just have a pile of data. They actually had documents of a particular style. Okay? So SEC filings or earning calls or city budget reports. They had, these documents had similar information in them, maybe more or less, give or take, different layouts, but really it was, you could think about it as a collection of things, not just random documents where you're looking for specific facts from them. And depending on the institution, what they wanted to do is not just ask questions about individual documents and chunks in those documents, but they wanted to ask questions about what was happening across all of those documents. For example, they wanted to do market sizing estimates, or understand how the police are being defunded, or understand, for example, for customer interviews, whether certain marketing messages were being effective, and how that's changing and what adoption blockers there are. So these tended to look more like analytics or analyses that you would do, okay? Looking for trends and insights. And the kinds of access patterns for these questions actually went way beyond what RAG can do. So the initial access patterns that we expected were things where you would have to find a needle in a haystack. I called them hunt-and-peck access patterns, where you're looking for small or maybe even large, but chunks of your documents that can answer your question from a very, very large corpus. And this is what RAG is really good for, okay, and answers those types of questions. But then there is another class of questions, or actually more classes of questions, where what you have to do is actually sweep through your data and harvest information, pluck out information that you hadn't potentially plucked out when you had loaded it, or dynamically pluck it out because it could only be answered at the time that the question was asked. When you bring all that stuff together, you still want to be able to synthesize an answer from what you've plucked out. And I call these sweep and harvest type questions. Okay? And RAG and all the other techniques that were out there, we just didn't see anything out there that we could use. And finally, there are questions where people wanted to synthesize two different classes of documents and kind of put them together to get answers. So simple examples of these things are, fastest growing companies and their directors and their compensation, or taking multiple passes over your earning calls transcripts and figuring out where CEOs have changed and what the outlook looks like for companies whose CEOs have changed. So why is RAG not enough? Well, I think we have to kind of walk back and go back a couple of years, and when kind of ChatGPT came out and everybody suddenly woke up and said, oh, AI, that's the answer, right? We all looked at it and started typing against the AI, and it could answer all of your questions, but it really wasn't an oracle. And especially for enterprise use cases where accuracy matters in financial services, healthcare, pharmaceuticals, and so on, it was just making up stuff, okay? We gave it a nice name called an hallucination, but it was just making up stuff. And the reason it was making up stuff is because it wasn't trained on enterprise data. It wasn't publicly available. And so a paradigm that came out was retrieval-augmented generation. How many of you know what RAG is? Okay, great. Last year when I gave this talk, or gave the talk when we launched the company, I think about like 1% or 2% of the people knew what RAG was. So this is kind of, throughout the industry, everybody's like, okay, yeah, I get it. We're going to stuff inside of the context of the LLM, and the thing that we're going to stuff in that context is going to be information from our private repos. And to be able to go and find that stuff, we're going to index it, and why not use OpenSearch? But you could use a bunch of other, but why not use OpenSearch, a full-featured engine? So this works, and the thought is, well, can we answer those analytics types questions using a RAG-like technique? And the answer is, like, you can't, right? There's a limited amount of context that these systems have. And while they're going to millions and tens of millions of tokens, it's not going to hold all the data that an enterprise has. That data is growing faster than the context is. The second thing is that the way these systems work is typically you're going to do some type of retrieval, and it's going to be a retrieval based on semantic content of the data. So it's captured in these numbers called embeddings. They're entirely opaque, right? So when they work really well, you get a beautiful answer. When they don't, you have no idea what happened. Zero, right? You don't know how to tweak it, nothing. And what we found as we added more and more data, these embeddings, was harder for these embeddings to discern from one chunk versus another. For example, if you were looking at a company and their earnings reports from last quarter or the previous quarter, they'd get mixed up, right? Finally, the sweep and harvest and integrate and synthesize type patterns that you see, RAG just doesn't do that. It's just only retrieving stuff from an index. And so we decided, we're database folks. We've been doing databases for a long time. We did it a bunch of different places. Why don't we take a database-like approach, right? But actually mix it up with the new technologies that were there. And so what I mean by a database-like approach is databases have this one simple principle. You ask a question over the underlying data that you have. In this case, it's going to be unstructured data. And the system should generate a strategy to answer your question. That's really what the fundamental basis of relational systems was when they were created about 50 years ago. And we're going to use the same principle here, except instead of using query optimizers, we're going to use LLMs to generate a strategy, a plan for processing these underlying documents and analyzing them. That's what we think of, or what I mean by unstructured analytics. Okay? These query plans, they can implement a ton of different types of patterns. They can implement the RAG-style patterns, the hunt-and-peck patterns. They can also implement the sweep and harvest and the synthesize and integrate. And they're going to be a mix of both logical operations, like simple filters and grouping and counting, the things that you're used to in the database, as well as semantic operations, things that you can't really program, but you can ask an LLM to go and assess for you. Was it windy? Was it warm? Was it cold? Right? The third thing that we found, of course, because these plans are built with LLMs, is that it's really important for explaining how you got the answer. So explainability is key. And the nice thing about a database-like approach is that if you have query plans, you've seen them in SQL databases, you have an explain, we can do an explain. And it's really important, inspecting the data as well as the steps that it took to get to that data makes it easier for you to go and build trust in your systems. All right, so let's see it in action, okay? What I'm going to show you is a collection of documents. Think about 100 documents that we've loaded from early 2023 that are from the National Transportation Safety Board about accidents, airline or airplane accidents that happen in the United States. Okay? And you can see that these documents are semi-structured. And what I mean by that is you've got images, there's a banner at the top, you got a picture of a downed airplane in here, and there's structured information. You've got a main table that describes the metadata for the system, for the accident, where it happened and the date and so on. You've got free-form text that describes what happened. A human actually entered it in the accident. And you also have a bunch of other metadata, sort of conditions and other things that happened around the accident. And so what we did is we actually took Sycamore, pulled out all of the sort of key information that we wanted to query over, in particular, the metadata fields at the top, and we loaded it into OpenSearch. We also took all the text and the tables and so on, created embeddings. We did all this with Sycamore. I'm not going to show you that today, but I can show you to you at the tables and the booths. We loaded into OpenSearch using Sycamore. So we created a metadata index, a text index, as well as a vector index for all the embeddings. So it's all kind of stuffed in there. Now let's take a look at what Luna can do. Okay, so I'm going to ask a bunch of different queries. First thing I'm going to do is I'm going to ask a query to kind of show you why RAG kind of falls over. Right? The first query is going to be a query about, I've kind of listed them here in an Emacs buffer so you can tell how old I am. The first query is asking questions about accidents that happened in the last, let's not do that one. That one's a little bit more complicated. Let's do the next one. List all the aircraft types, cutting and pasting them because it's easier than typing them out. List all the aircraft types involved in accidents in California in 2023. Okay, so a RAG system, what it's going to do is it's going to create an embedding for that query, look for nearest neighbors, okay, and then bring a bunch of chunks back and ask the LLM based on those chunks what the answer is. Well, if you have to go through 100 documents, not all these documents are actually going to fit in the context. So, I have no idea, whether this thing is going to get the right answer, whether it's going to hallucinate an answer, whether it's even going to get answers about aircraft in Texas, because who knows what the embeddings are going to bring back for you. So let's take a look. Okay. You'll see in our system, we not only ask the question, but it tells you the type of query that we're running. Okay. So far, we're just kind of getting started here. All right. The tool response basically is what came back from the underlying OpenSearch engine. I'll expand that in a second. Let me show you the query, actually. This is a hybrid query, a hybrid search query. For those of you that used OpenSearch, this is how you enter a hybrid search query. We've rewritten the question in a sort of cleaner form so that the RAG system can bring back the right answers. And it turns out it's brought back 8, 9, 10 different aircraft types. And here's an example of one of the aircraft that that crashed. And you can clearly see this is wrong. Okay, brought back an aircraft that crashed in Yoakum, Texas. So again, embeddings, what they're really designed to do is give you a result set so that you can do search. Okay, they're not great at analytics where you have to kind of sweep through your data and find the right things and give you an answer that's sort of much more precise. So it turns out that this answer is actually completely wrong. It's got airplanes and from all kinds of different places. The right answer has only 7 airplane types. Okay, so let's ask this using our Luna technique, where we create a query plan over this. Right? So now you'll see that it's generating a plan. Okay, and the plan that it's going to generate is going to have a couple of components in it. Okay, it's worth actually taking a breakdown of the plan. It's got 2 nodes in it. The node here at the top basically says query the database. In this case, the database is OpenSearch. And you can see that it's taken the question and rewritten it so that you're looking at things that are happening in 2023. And we're looking for accidents where California has specified in the location. So this is an exact match. So I know I'm going to get California accidents. I'm not going to get any Texas accidents. Second thing that I'm doing, this is actually an LLM type operation. The top K is a misnomer. It's really a grouping operation. We're going to group by the type of aircraft that we see. We're going to count the number of accidents that we see. That's the second field here. Okay. And so I'm pretty sure the query is done. And it got the right answer. So there are 7 different aircraft. But how do you know it's the right answer? I don't know. Let's take a look at the trace of the query. So that's the other thing that the Luna system here really kind of requires you. I shouldn't say require, but makes it much easier for you to understand what's happening in the system, so you can build trust in it. Is that you can see that all the accidents up here happened in California. That's what we got back. That was basically a strict search, right? So you know that these answers are probably right if you did the ETL right. And it turns out every one of them only occurred one time, each of these various types, and so here they are. So it's probably the right answer, modulo what you put into the system, right? It's about the best I think you can do. If your data is clean in your system, you're going to get the right answers. If it's not, you're going to get whatever answers based on the data that you have. Let's do another one, a little bit more complicated here. Okay, and it's really fun to actually play around with the system to see what kind of query plans it's going to come up with. It kind of surprises me each time. So let's see what it does this time. Okay, this one is sort of a more complex question. The question is, show me aircraft incidents in California in 2023 when the wind was stronger than 4 knots and there were serious injuries. So you can see that there's a little bit of judgment that has to happen in this question. What does it mean to have a serious injury? There certainly is a field that says injuries, but if it's fatal, is that serious? Okay, right, good question. It probably is. Right? So let's run this question. It's going to come up with a plan. And of course, all this stuff, by the way, all of this planning, all of the sort of LLM operators right now, you can pick and choose your models. Right now, we're just using GPT-4o. Okay. So there it is. There's the block that it automatically picked up for getting incidents in California in 2023. And then you have these 2 operators here called LLM filters. Right, so this LLM filter is actually filtering out for speeds greater than 4 knots using an LLM. Why are we doing that? Well, it turns out in the wind speed field, people are actually typing this in. Okay, sometimes they type in 4, sometimes they type in 4K for knots, 4 knots. They'll put a slash next to it, all kinds of variations. Right. And we didn't happen to actually think about cleaning that up before we loaded it in. So it turns out that the LLM filter is actually quite useful here for picking out the right the incidents that happened. Then the next one is about whether the injuries were serious. Well, clearly, we have a field here that says injuries. Somebody has to kind of type those things in. Sometimes that field is null. Sometimes there's information there. We're going to ask the LLM, whatever you see here, let us know if it's serious, bring it back out. Okay? So there's going to be a certain amount of judgment, and your mileage is going to vary depending on the LLM that you're using and how it kind of interprets it. So here's the answer. There's actually two. They were both above 4 knots. And yeah, the LLM thinks that these are both serious accidents. You can see that the injuries, there's actually an injury type called serious, and then there's also a fatal injury that happened. If you wanted to kind of take a look at one of the documents, here's document number 12. I'm sure we can, it is from California, so matched our filter, has a serious injury in it, and the wind speed was 7 knots. I don't know if you can see that, but that's what it says there. Okay, how do I know it's right? I don't. I'm going to have to basically look at the query trace and kind of walk through what happened and gain some confidence that it's doing the right thing. And I might want to actually go back in different parts of the query trace and start asking questions about that data just to make sure that I'm actually working on the right set of data and it's getting the right answers. So here are our documents again from California. There were 4 of them that actually had wind speed greater than 4 knots. You can see the wind speed here is 6 knots, 12 knots, and so on. And some of them actually don't specify whether there were any injuries or whether any injuries even happened. I think 3, none, basically nothing happened. And so the LLM basically picked out 2 of them that it thought were serious. Okay, there they are. So you see how this kind of works, right? You ask the question, I have explainability, I also have understanding of what's happening at every step of the process. And as we're working on this, we're going to start, we already have in Sycamore the ability to track lineage. You can actually go all the way back when you get an answer to the source of where that came from. All right, I can keep playing around with this and burn up all my time here, but let's kind of talk about how all this stuff is actually implemented and how it works within Sycamore. All right, so we saw it in action, all right? Well, the first mile of all of this is doing the ETL. You got to pull the stuff out of your PDFs. And it turns out, when we first started working on this, we thought, oh, this is going to work great. There's all these services out there, there's tools out there. Well, it turns out it's a complete zoo, okay? And they don't always work for the kind of documents that you have. And so we actually worked on this problem a little bit, came up with a brand new modern vision model. We actually treat all these documents as images. And that vision model does a phenomenal job. It's better than pretty much everything else that's out there, 4 times more accurate, faster, and cheaper. It does a phenomenal job of pulling out tables, images, and text from the underlying data. We turn that into basically JSON. So, using the Aaron partitioning service, you can go try this on your own. And we feed it through our ETL software, Sycamore. It actually pulls it from the partitioning service that we have. And then Sycamore will do the various transformations you need to do, turn tables into key value pairs, get English descriptions of images, and so on, using a data flow-like paradigm, very similar to Apache Spark, but we've built this all entirely in Python and integrates really well with a whole bunch of LLMs. And also, just check this out, go download it, it's 100% open source. And then we store all of this into OpenSearch, which is the engine that we all know, that's tried and true, battle tested. And the reason we do that is because it's got vector indexing support, text indexing support, metadata indexing support. You can do lexical search, you can do hybrid search, you can do aggregations, you can even do small types of joins. So it's all there. Now we just need to orchestrate all of it. So this is why starting with OpenSearch was so important for us. All right, does it really matter, right? And a lot of people are like, oh, the LLMs, they can clean up your stuff. It'll be fine. Just give it the garbage and it'll just clean it up and give you an answer. The answer is no. That doesn't work, right? So you can just run basic RAG with some standard OCR techniques that are out there, standard parsing techniques that are out there. And you'll see that, both in the customer workload where we were building a customer support assistant for internal users, and for an external benchmark, Finance Bench. It's really a RAG benchmark, but it has some components of analytics in it. Just starting with just simple basic RAG, you don't get the right answers. Okay, 55% recall at 10 is terrible. Like it's painful when you don't get the right answers. You're just going back to your previous mechanism. Then if you do sort of, you pay for sort of some more better sort of ETL techniques, maybe not vision-based, maybe just text-based, you can actually do a lot better. But if you pull out every element of a table, every element of a diagram or a flow, and then ask the questions, turns out that it really bumps up your accuracy. Okay. In Finance Bench, we've actually gone even further than 69%. There are other additional techniques that take us all the way to 77%, which is basically state of the art right now in Finance Bench. And we basically nailed the customer workload for the support assistant that we were building. Okay. So what kind of operators are we talking about in Sycamore that we want to support? Okay, so how do we actually do the Luna part of the querying? So we added a whole bunch of new operators in Sycamore. There were the traditional ones that you all can probably think about, probably think of, querying a database, right? I'm just pushing down all my information into the database to get the database out, doing lexical search, materializing the results into a temporary place, maybe S3, filtering, the simple ones, right? Grouping, aggregation. So we got all of those operators. We also have a bunch of semantic operators. Your mileage is going to vary based on what semantic operator you're going to use, but we have vector search, hybrid search. We also have LLM filter. You give it a question, like a predicate. It tells you whether the document passes or doesn't pass that filter. Pretty simple, right? But very powerful. And the reason it's powerful is you're asking your LLMs, instead of asking them, hey, compute this answer, you're actually focusing them on the very specific task you have at that time. And that brings up their quality, their reliability, because they're only doing that one thing. Okay? LLM extraction, imagine you forgot to pull out a particular piece of metadata, like maybe locations or names or whatnot. Again, you can just prompt an LLM to be able to do that. We also have this thing that's a semantic group by. These groups, group by the regions of the continents of the world, or group by the climate regions that you find in the world. These are things that are kind of fuzzy, right? Like LLMs actually do a pretty good job of identifying these things, and you can do the semantic group by. And then of course there's a summarization operator. All right, so how do we do the planning? The secret sauce? Well, it turns out it's actually pretty straightforward. It's all prompt engineering at the moment. Now we have to get better at it. Right? There are things that are going to break the system, and you can come to the booth and try to break it, and I'll give you a little t-shirt or a little ducky, depending on what you want. We have these character duckies out there. But the LLM prompt is very simple. We actually give it a little bit of preamble telling the LLM what it's supposed to be doing. We give it the schema of the data that's in OpenSearch, tell them about all the operators that we have, and give them some examples. And we ask the query. And it outputs a logical plan. Here, that's what I showed you in the demo, right? That was the logical plan. Behind the scenes, we actually turn that logical plan into code. We actually generate Sycamore scripts, okay? And those Sycamore scripts then run and actually compute the answer, give you and that's what you see in the UI again. The nice thing about that is we don't have to worry about how to actually run the logical plan. The logical plan can be run by Sycamore, which is the scale-out data flow processing system. So depending on whether you have a small amount of data, larger amount of data, it kind of is taken care of for you. You just have to worry about what the operations have to look like. All right, that's it. That's the magic, right? So I want to leave you with a few parting thoughts, and then take some questions. One thing that I want to stress and emphasize is explainability, and the ability to kind of follow up and iterate with the data, right, is essential for unstructured analytics. What do I mean by that? Well, let's take a look at where, I like to quote this insight from Terence Tao. It says, today's modern AI are incredible guessing machines. They generate answers for you remarkably well, but they do hallucinate. And they've been quite successful when you can independently verify their output. okay? And so the most successful use of generative AI in the enterprise that we see today is code generation, right? How many of you have used Copilot? Raise your hands. Okay, if you haven't, catch up, guys, like everything's changing, right? Or ChatGPT, I'm sure you've all used it for generating code. And you interact with the system, it generates some code, but there's a verification, implicitly in that process, there's verification that's happening. Humans are looking at that code and checking to see if it's done well, and if not, they basically repeat or hit refresh, and then they actually put the code into their systems and test it. Otherwise, the whole process is useless. And if you think about unstructured analytics, Luna, we're actually doing a similar thing. We're actually generating code. The code that we're generating is to answer the question that you're asking. How many planes crashed in the Mojave Desert? 21. The problem is that we don't have testing. We have only humans in the loop, okay? And so it's really important to be able to have explainable answers, plans that you can inspect, data that you can inspect, and the ability to follow up to make sure that the system is behaving the way you want. Even ask questions over intermediate results to see if you can come up and sort of verify the answers in different ways. All this stuff actually builds trust in the system and in the answers that you're creating. And normally, you wouldn't be doing any of this. You'd be doing this all by hand, okay? So you might ask me, Mehul, you're still getting bad answers still, right? You still have to do all of this work. Well, it's a lot better than humans doing it. And you might ask me, well, are the AI good enough, right? And if you look at what's happening, right, in the market, is that the AI performance of various models on various benchmarks is basically nearing or exceeding human performance now. So where there were previous paper processes where we were using humans, an analytics type solution is probably going to give you better quality than if you just kept the humans there, even if you believe that the humans are right. Okay, based on what we're seeing in the market. Maybe we're not quite there in all the use cases. So image classification, these things are way better. Competition math, not yet. Right? Then you're going to ask me, you're going to be like, but Mehul, this is really expensive. Right? Well, yeah, it is. I've paid some OpenAI bills in the last few months. I understand. Right? But if you take a look, there are a lot more capable models out there in the open source ecosystem that you can use. And remember, we've broken these things down to individual operators, so you don't need this general intelligence for these kinds of use cases. You can use open source models that are distilled, smaller, faster, cheaper. And if you take a look at what's happening even in the AGI models like OpenAI's, you're seeing their prices dropping 10x per year. So I predict, or at least that's where we're kind of investing our efforts, that people are going to be using these models, both open source and proprietary, much more liberally. It's not going to be just at the end of a flow, which is what you see in these RAG systems. Right? And you're going to have much more complex interactions amongst these models. These compound AI systems are going to emerge. Already seeing that in various places. You're going to see this in analytics over unstructured data. All right, to conclude, I know I said a lot. You came in late maybe. Thank you for coming in and talking and listening and coming here. But the one thing I want you to take away is the current approach of RAG is not enough. Okay? It's not enough because it doesn't answer the questions that users want to ask in enterprises. They really want to have patterns that kind of match what you need for unstructured analytics. Luna, our approach for all of this, uses LLMs to generate database-style query plans, right? Not necessarily just search. Search is one of the components there, with a mix of logical and semantic operations to answer these questions. And it actually works remarkably well. We still are, we have a bunch of tools to kind of narrow the gap in verifiability, right? To be able to inspect and navigate the data the answers that came back and the data that created those answers. And that helps you kind of build trust in the systems. So with that, I invite you to come get started and use our systems. We have the Partitioner as GA. We have Sycamore that's GA, which is open source. Please go download it. All of this stuff is actually open source. If you want to contribute, please send us email, join us on Slack. There's a bunch of different ways come to the booths in the back. So thank you very much, and I'll take some questions.